space shuttles were not painted solely for aesthetic reasons, but for critical engineering purposes. NASA's early designs envisioned a fully white orbiter aiming for visibility and thermal regulation. However, they quickly discovered that paint added approximately 600 pounds to the shuttle's weight. Every pound was crucial because it directly impacted the payload capacity of the spacecraft. Consequently, engineers decided to omit paint on large portions of the surface to optimize weight. The shuttle's surfaces were divided based on thermal and safety considerations, leading to different coatings. Thermal protection tiles covered the bottom and sides of the shuttle, and these were not painted. These tiles were composed of silica-based ceramic material, naturally white or black in color. They were specifically designed to absorb and radiate intense heat during re-entry into Earth's atmosphere. Applying paint to these tiles would interfere with their heat dissipation properties. Black tiles located on the belly and wing leading edges were not painted but made from inherently black material. Their natural color was a result of the baked-in heat-resistant properties of the material. During re-entry, these black tiles could reach temperatures as high as 2300 degrees once to 260 degrees. The thermal tiles' color change under heat exposed their function in extreme conditions. White areas on the upper fuselage and payload doors were covered with a thin reflective coating. This coating was applied where temperatures remained lower compared to the heat zones. The reflective paint helped shield the shuttle from UV radiation and solar heating effects. The shuttle's iconic black and white aesthetic was rooted in engineering realities rather than design choice. Black areas indicated regions exposed to the highest thermal loads, while white regions remained cooler. Minimizing paint on the shuttle reduced weight, thus allowing more cargo to be carried into orbit. Applying the paint was a meticulous process involving manual work with rollers and spray systems. Engineers used precise masking techniques to avoid covering sensitive tile seams during application. Each orbiter required weeks of inspection and touch-up before launch to ensure safety and durability. NASA was wary of changing the appearance due to potential impacts on heat absorption and safety. Any color alterations could necessitate years of recertification to guarantee performance. Because of these factors, the shuttle's distinctive look remained unchanged for nearly 3 decades. After initial testing phases, NASA removed most of the white paint to enhance payload capacity. This modification contributed to the final, confidently recognizable black and white scheme we see today. The design evolution highlights how engineering constraints influence iconic space vehicle aesthetics. In essence, the shuttle's paint design was a carefully calculated compromise between safety, weight, and efficiency.